a pinwheel or a pie chart.
Yeah.
And that's not probably the best way to show this, but if I show you the variable information radius, and between two samples, again, pretty boring. But if I mouse over it, it should give me, oh, yeah. I thought it would give me back that same number. We can do the same thing for joining. So this is a measure of the difference in clonotypes between the two samples.
Yeah.
But because it's a difference between only two samples, you get this symmetry across the matrix. You can also look at clonotype diversity. So what this is telling us is that sample 2 has a bit more, it looks like 2 clonotypes in common with sample 1. Well, then why doesn't sample 1 have?
Yeah.
There's something weird about that.
I was just wondering if you could just do the whole, 2,000 whatever, the 2,000 cells for
Yeah,
sample.
just comparing 2,000 cells versus 2,000 cells.
Yeah.
Is that what that is?
Yeah. This is sample 1 versus 2.
Oh, I see the whole thing. I thought you were picking it because it doesn't look very heterogeneous. You had a pinwheel that had V, D, J, and light chain, that kind of thing.
Right.
That showed
yeah,
this.
So those would show up if we had more populations to compare
Yeah.
in terms of like this variable information radius. Let's try and see if I can do a quick graph here. Oh, we don't have any components in it. I'm sorry. How do I get this quickly?
Well, I was thinking, I don't know, maybe I misunderstood, but the 0 to 360 has different V regions, and they have different D off of those, and different J, that kind of thing.
Mm-hmm.
You don't have those kinds of things. I thought that was what you had. I mean, your example was day, weekday, day, week, month, year, that kind of thing. So it looked like something like that. Like at the first ring shows some like heavy chain, and then the outer ring shows V region, or no, whatever. I'm not sure, but something like that has information on it about.
Right. So the only thing we currently show in a pie chart that you've probably seen in the previous example is the Jensen-Shannon entropy index or information radius. The closest I think we can do right at this moment is this comparison. Like, for example, these are diversity genes, obviously, between the two different samples.
Yeah.
You can see where maybe some is overrepresented in like sample 2 here, and some might be overrepresented in sample 1. But actually, what we proposed is something we thought of early on, showing a pie chart with different regions shown all at once, so to speak.
Right.
And if that's something you're interested in, yeah, we could look at that for maybe not the next release, but a future release for sure.
Yeah.
That sounds actually pretty cool. I mean, that's something we got.
Well, one thing I have that I haven't seen is I know there's V regions and then they're connected to different J and so forth, but I don't see like a way to illustrate VDJ, all of them, V, and then which D's are used with that V and J. It's like a grid, V down at the bottom on the x-axis, and D and J on the y-axis, something like that.
Okay, I'm taking note of this.
A grid of what, comparing, like for a given V, what D and J does that prefer to use? That kind of thing. And the same for light chain. Or actually for a given antibody even, what V and then D and then J and then which lambda or kappa and what V do they have? Sort of like just a density plot.
So yeah, that's a good question. There's a couple of, it's possible we could do something like that. There's one problem that comes right to mind, but let me see if I understand something else first, and then we'll back up into that. So the CD3, CDR3 region here, is this in some way expressing what you're describing?
Yeah. Yeah, that's it, because it shows the joining region, the CDR3. It doesn't have a good name, but any of it, if that's the name, it's going to be hard to work with it because it's, but in any event, and then it has I looked at, yeah, has a variable region, the diversity. Oh, it has a name, yeah. Then it has a joining, and finally the constant region. Yeah, something like that. In fact, you know what would be very interesting for us? If we could get a CSV file for that and then export it and show it in ClustViz, for example, something like that. So it's a heat map of all those things, and then they're clustered together by some method. I asked, that was one of the questions, how do I export like something like this into ClustViz? If it's possible. Or not ClustViz, a CSV file of this. Is that possible?
It should be possible. It's not in currently what you could export as data is just like this bar chart.
Yeah.
You don't have an option to export this table yet. But I'm writing down export quantified CSV.
Yeah, CSV file for some limited set of things, or not, maybe not so limited. But exactly this would be great. And then, of course, there's a redundancy here because it has chain on the beginning and then constant at the next to the last, and they're redundant. But in any event, I think. That doesn't say IGH and IGM. Okay, so they're not redundant. So all this information, and so we can plot, look at density and groupings of one person versus another.
Okay. Yeah, I think exporting this as a CSV file is totally easy to do. We can include maybe another button here, or maybe this export data.
Yeah, what about that export data? What about that? What have you?
So this should export this bar chart.
Oh, okay.
Which is just a variable view.
Right.
The other thing, the way you mentioned it, thinking about almost like you bring up a plot, right? Just a density plot.
Right.
Where you had, maybe your DJ options here and V on the Y-axis.
That'd be good.
The problem with that is that you have this many-to-many map. So not like certain cells have multiple different V regions that they're expressing, right?
Yeah.
And in which case, how do you create a single dot for that one thing? Maybe you don't. Maybe you have multiple cells or multiple barcodes shown within that plot. I'm not sure. We haven't wrapped our minds around that one yet. That's kind of why we didn't just include the meta information in new parameters.
Well, maybe I can say it like this too. Another way to say it is if you can do something like this. What we want to do is identify maybe, I think I said this too, 5 or 10 heavy and light chain cells. The cells based on something. It could be expression of interferon genes or interferon response genes. But we want to identify a group of cells in one person. It's similar to what Binga was just saying. We want to identify a group of cells in one person that's maybe different in another person based on, say, their phenotype, and then it's hopefully a small number, but it's a meaningful number. And then for those, we want to see what their immunoglobulin expression is, heavy and light chain. Because the idea is then eventually we're going to, not even eventually, but very soon, we want to send those sequences, that's why I was asking about the sequences, those sequences off to be made into actual antibodies. So we need to narrow it down. We can't do 2,000. We just have to do about the top 10 based on almost anything reasonable, and then we'll see if it really works. I suspect there'll be some trouble at the next stage, that is making the antibody. But
Sure. So one idea that we had for that, in this case, it looks like all of these top 20 phenotypes came from sample 1. Mm-hmm. But there's ways we could get only the phenotype from sample 1, only the phenotype from sample 2, and we could look at differently expressed genes between the two. That's one idea. There's a number of ways we can parse this. Once we have the clonotypes of interest as populations within sequence, then it's almost kind of infinite number of directions we could go, depending on how you want to guide that process to discover, the genes of interest.
Well, one thing I was thinking of is if you go back to a phenograph of one of the two populations, right? So go to the phenograph, and which population, which person, 165 is the sick one? So, I mean, I would settle for something like this, a phenograph of 165 versus 166, and find what you consider an interesting population in 165 based on phenograph that's not in 166, and then we'll look at what those parameters are, and then what V regions are in the cells in that population. Something like that would be acceptable.
Okay. It sounds like when we get to the point where we're looking for what V regions are in that sample,
Right.
we would need a gene set that contains all V regions, which shouldn't be too hard to generate. Actually, have an idea how we could do that already.
Right. So if we see something interesting in 165, right? I think I'm just repeating what I said, but 165 versus 166, and then we can say, is it really neat? Is that really, telling us something about the biology? And then then we'll look at the genes and we say, oh, that's interesting. They're this set of genes or that set of genes. And from there we say, okay, let me get a few of those cells, or all of them, say, and get the heavy and light chain that's in those cells.
Mm-hmm.
So is that 165 versus 166 right there? Is that what you got?
This is actually 165 phenograph versus 166 phenograph, but I'm not sure I like it very much. I think what I want to do, probably want to start with where in these principal components are 165 and 166 different.
Mm-hmm.
Or distinguishing from one another, if anywhere, because they might perfectly overlap.
Right. Oh, a lot of them overlap, I'm sure.
And if they don't overlap, I would worry about batch effects. But it looks like, remember we mentioned that the B cells seem to be absent for the most part of this cluster and this cluster? So it looks like maybe a lot more contamination in cluster
Right.
160, or in sample 165 relative to 166.
Yeah.
Right.
That is true.
We can deal with that. I mean, it'd be nice to eliminate those from the cluster of Tisney because, or whatever, because we don't want that to influence it. We just want the B cells to influence. There'll be major dimensions if there's a different population. But like if you gate on the CD19 first and just use those for this PCA, can you do something like that?
Yeah, so I gated on CD19 positive, CD3 negative,
Okay, yeah.
and then I put the different samples there so I can distinguish between the B cells from each.
I see. That's what you have up there now?
Right, exactly.
Huh.
So
So,
they're going to be dark green and light green. And then what I'll do is set this color to gray, and I'll remove these other two.
maybe you can make it a different, like a sort of a different color now, like blue and red or something. If you make 65 red, 'cause we want to find, and 66 blue. Or,
Yeah, so they do overlap.
yeah. Well, and 60. Okay, so 65 is green. All right. So now what we do is, I don't know what this population is down. The lower right one. This I can't point to it, but there's more green than red. You see it down there. So can you find out what those are? Those like list the genes, and I'm just saying I don't know what that population is, but you see what I mean?
Yeah, I think so. The other thing I would want to do here is now that we have B cells isolated, if we're happy that these are our B cell populations we want to look at,
Yeah.
then we can kind of repeat some of the previous step, just in terms of quality control, and then look at like a T-SNE plot of just B cell.
Yep.
if there are clusters that distinguish between 165 and 166, or might be of interest in that regard,
Right.
and then we can ask for differential expressed genes there.
Right.
Hopefully, I would hope that we'd be able to do the VDJ exploration of that.
Right. That'd be perfect.
Okay, yeah.